it's an exciting enough approach that we're standing here telling you about it. So I think this is my last slide here. So there was a recent paper at CCS 2009 that was talking about, it's called On the Difficulty of Software-Based Attestation of Embedded Devices. And so it goes through and presents several attacks on software-based attestation schemes that are actually out there in practice. Some of those attacks were on schemes that were developed here at CMU. The paper has it makes some interesting points and has some valuable contributions, and it also has a few issues. So there's a rebuttal paper available at the URL here if anybody's curious about reading about the exact details of kind of what's cutting edge in the software attestation space. So before I move on and talk about the remaining speakers and the plan for the rest of the workshop, does anyone else want to ask any questions?
Do any of the software attestation mechanisms today, are any of them suitable for use over a lossy network like the Internet?
So the question is, are any of these suitable for use over a lossy network like the Internet? So there's a couple of different points. Let's not worry about lossy yet. So the biggest problem is you have to understand the hardware configuration of your device. And because we don't have secrets, we have no PKI to tell us we're communicating with the right device. So if your device is the fastest supercomputer on the Internet, it could work. But if your device is anything less, then you have no way of knowing if the challenge was redirected to a more powerful device. Lossy, you just need to get a quick routine and try it enough times. Yeah.
You're saying also that you can't distinguish between two similar vintage devices on the same network right next to each other.
That's right. We assume that we have a network connection that provides host authentication implicitly, like a cable. So authenticating the communication endpoints is kind of another one of the assumptions that's made.
Kind of hard to keep tags on long cables.
It can be difficult to keep tags on long cables. So that's a good transition, actually. So there's going to be two more speakers in this workshop. One is Yan-Lin Lee, a student here, and he's going to talk about software-based attestation for peripherals. And so inside your computer system, you don't just have a CPU and memory. You have a really powerful CPU and memory, and then you have a somewhat less powerful graphics CPU, still with quite a bit of memory. And you have a lot more CPUs, each with some memory, in your chipsets and your peripherals. And so, as I alluded to with some of the manageability interfaces and DMA-based attacks, these are all also subject to attack. And so, one of the places where this approach may actually be compelling is if you have a system where you have maybe hardware support to verify that the stuff executing on the main CPU is the stuff that you want there, but then you want to somehow verify all the peripheral devices or component devices of your system. So Yan-Lin's going to talk about that. And then Marcus Jacobson's going to talk about practical and provably secure software-based attestation. So I actually am not aware of exactly what his latest results are, so that should be pretty exciting. And then after these guys tell us about some of their work, we're going to go to the panel format and have open discussion. Okay, so if there's no further questions, I'm going to invite Yan-Lin to come up and... Yeah.
Just one question. It seems to me as though CPUs tend to have varying speeds, and they get sorted by how fast they are. They don't all tend to be the same. Do you have to really know the particular CPU you're doing the test on as well as...
Yeah, so the question is that there's a lot of variation in CPUs, and they don't necessarily all run at different speeds. So an assumption slide may have been a good addition, but overclocking is a way to attack this. If you can, crank up the clock frequency of your processor to the point where the instruction or two that the attacker needs to add is not a noticeable overhead remotely, then that can be an issue as well.
What's the thinking about that so much as maybe you have two devices that look identical, but one of them was a faster chip in it than the other one. Do you have to kind of tune to the particular hardware you're looking at?
Yes, you do. So this is kind of a combination of needing to have the end host authentication property and then just knowledge about how long it should take that routine to run. Now, I mean, you can imagine a family of devices that are similar, and you can maybe analytically say, well, this is the version that's X% faster with X% more cache, and its verification time should therefore change by Y. You do need to know which one you're talking to. Please.